is a projectiles question. It's question 2 from this practice paper from February 2022, the CCEA 2 Applied Maths paper. So let's take a wee look then at our question 2. An athlete throws a shot put with a speed of 15 at 38 degrees to the horizontal. The shot put is thrown from shoulder height, which is 1.6 above the ground. Model the shot put as a particle. Find the time taken to reach the ground. So in this case, we're going to take the vertical motion. So U, V, A, S and T are U. If it's kind of thrown up like this, and that's 38 degrees, then this here, and that's going to be 15, it's going to be 15 sine 38. V we don't know. A is going to be minus 9.8. I'm picking upwards here to be positive. S we want then is minus 1.6, and we're trying to find then our time. So we're going to use S equals UT plus a half AT squared. It's quite a messy one, to sit and work out, but we have minus 1.6 is equal to 15 sine 38 T minus 4.9 T squared. Hopefully you're happy where that comes from. So that's half of the 9.8 there. This is now a quadratic with T. I'm going to take everything over then to the one side. So you get 4.9 T squared minus 9.2349 T minus 1.6 equals 0. These days we can just stick that into our calculator and get our two possible answers, and so we're going to get T then is minus 0.16, which doesn't make any sense, or 2.0444. So the three significant figures then, time is going to be 2.04 seconds. It has been reported that the athlete has broken the world record of 23.37 meters. Find the horizontal distance by which the shot putter beats the world record. So here then we're going to have horizontal motion, and it's effectively speed, distance and time. So our U, I guess, then is going to be 15 cos 38, and our T is going to be 2.0444. Our S is U times T, so our S is 15 cos 38 multiplied by 2.0444. Put that in your calculator. 15 cos 38 times 2.0444, and we end up with 24.1651. So the record was 23.37, so we subtract that. So 24.1651, take away 23.37, that's 0.795, then the three significant figures. In 1970s, sports analysts were puzzled that the best shot put distances were not occurring with a projection angle of 45 degrees, which was known to be the optimum projection angle of a projectile. Suggest what they were not taking into consideration. Well, the clue was in the question earlier on, but it's kind of quite a tough one still. If you are projecting this, it's not being projected from the ground. If it was being projected from the ground, then 45 degrees would be perfect. But because it's not being projected from the ground, then we have a different option there. So that will not get your mark. You need some sort of statement. So didn't take into consideration height of projection above the ground.